Good morning, good evening, and good afternoon, wherever you might be watching this video. Hello, guys, and welcome to the Convert channel. I'm Mansur Amini. In this session, we are going to take a look at how to size a line. Especially in this case, we are going to use a real industrial project. This is the PFD of the gasoline hydrotreating unit, which our gasoline passes through the many fittings and control valve and all the way reach into the filter. So I'm going to size a line of these gasoline feeds. So let's get and at the first we need to learn the concept of the line sizing. So we have the Q, which is the flow rate of the feed, which is equal to A, cross-sectional area, and velocity. So we all know that the cross-sectional area is equal to pi number multiplied by the D or diameter of the pipe and divide this by 4. By mixing these two formula, we have the D or internal diameter of the pipe, which is SQRT, or the second root of the 4 multiplied by the flow rate, and divide this by the pi number, and again multiply by the velocity. So we have the 4 and pi number, as well as flow rate in the heat and material balances. So we need to consider recommended range of the velocity for the liquid hydrocarbons. For the liquid hydrocarbons, our recommended range is something between 2 and 3 according to the Worley Parsons design practices. So let's check it out. For type of services, our services liquid in the carbon steel, and our recommended velocity for the 800 kg per cubic meter is equal is something between 2 and 3. So let's get into the Excel and calculate the internal diameter of the pipe. Press equal. We have the actually flow rate of the feed, which is given, and density and viscosity of the feed as well. So we have the to change unit of this feed into the second. So divide cubic meter per hour into the cubic meter per second by dividing this by 3600. So our recommended range of the velocity is something between 2 and 3. I'm going to take the actually average of these two as our actually first trial. So for the internal diameter of the pipe, we need to type the SQRT, or the second root of the 4 multiplied by flow rate, divide this by the velocity, and again divide this by the pi number, close up the bracket, and hit enter. So we have internal diameter of the pipe. We need to change it into the inch unit. Press equal and write the convert command. I missed the V, and select the unit which you're going to convert it from meter into the inch, close up the bracket, hit enter. So we have 8 inch for our calculation. What do you think? Is that a correct calculation for our line sizing in this case? No, it's not. Why? Because we didn't actually consider a conservative point of view. In pipeline sizing, we need to calculate our the size of the pipe by 20% of the margin when our services is out of normal situation or circumstances, and we multiply our flow rate by 20% of the margin from the conservative point of view. Just hit enter, and our calculation or internal diameter of the pipe is 8.8 inch. So let's get and calculate differential pressure. We need to understand concept of differential pressure or frictional factor, which we need to understand the formula. We need the fanning factor, which actually Moody factor that we gained from the Moody diagram, and multiply this number by 4 to turn it into the fanning factor, and again multiply this number by the density of the liquid and velocity, which is powered by 2, and divide this by 2 and multiply all this number by length or equivalent length of the pipe, and divide this number by the internal diameter of the pipe, and we need to divide this number by 1000, divide this equation by 1000 to turn it into the from actually Pascal into the kilopascal. So let's get and calculate the differential pressure. Just press equal. We have 4 multiplied by the frictional factor, again multiply this by the density of our fluid, again multiply this number by the velocity, which is this cell, and again velocity, divide this by 2, divide this by 1000 to turn it from the Pascal into the kPa or kilopascal, and again multiply this number by the L, which is length of our pipe, and divide this by the internal diameter of the pipe. Make sure that you choose the right cell between meter and inch unit, because we calculate the differential pressure in the kPa unit. We need to select the meter unit as our internal diameter of the pipe. So hit enter. So we have 11 kPa or kilopascal as our differential pressure. So let's get back to the design practice, which says for the 100 meter of the pipe we have maximum differential pressure of 19 kPa or 0.9 bar. So what do you think? Is this calculation correct? No, absolutely it's not, because we haven't considered our fitting of the fluid. If we get back to the PFD, we have many fittings just right here, especially this flow control we have the feet, we have many fittings and transmitters, as you can watch, especially this flow control, and it goes up all the way. We have an elbow just right here, and again all the way through the gate valve and reach to the actually filters. So how can we calculate these all fittings in the basic design of our calculations? So let's get back to the Worley-Parsons design practices, which says for 60 meter of the pipe length and internal diameter of 200 millimeter and greater, we need to actually multiply our length by 2.4. So let's get back to the Excel and press equal and multiply this number by 2.4. Hit enter. We have 26. For 100 meter of the pipe, our maximum allowable pressure drop is equal to 19, and for 145, which is length of our pipe, in this case actually equivalent length of our pipe, which is equal to 130 actually maximum differential pressure. But generally we consider for 100 meter of the pipe it's something between 10 and 13, and for 115, which is our length of our pipe, something between 15 and 45, which our calculation or our actually design differential pressure is within the range, and our velocity is actually also within the range, and you can change your velocity and find other size of the line as well. For example, I turn it into 2.3 and our differential pressure decreased by decreasing the velocity. So our pipe inside diameter is 9 inch. Because we do not have any 9-inch pipe in standard units or standard pipe line, we consider 10-inch as our calculation. As you can watch, our calculation is correct. That is equal to 10-inch. So I hope you the best of luck into the next step of your career. Don't forget to follow my channel. Don't forget to subscribe and share it with your friends. Thank you guys. Have a good time. Bye bye.